Machines have always served us, made our lives easier. Actually, through machines, we harness the power of the universal forces that are already available in this universe, such as gravity, thermodynamics, electromagnetic forces, and others. However, because of these same forces, machines sometimes cannot fulfill their purpose. They fail. Gravity, friction, magnetism, and thermodynamics negatively affect them and damage the machine. We call this situation failure. Failure is inevitable fact. You cannot stop it forever because you cannot separate the machines from these forces. But you can manage the failure, postpone it, minimize it, and lower its damage. Failure is something you should fight because with failure you lose time and money and quality and quantity. Failure causes more risk for people, machines, and the entire system. Since the beginning of the machines, people have developed different methods to fight failure. Reactive method was the first one. It means run until failure, then repair it. Preventive method is another one. It's time-based maintenance. Something like changing some parts of the machine regularly to keep the machine young and fit. And with the development of the monitoring techniques, continuously monitoring the machine's condition and acting based on the condition become popular. With the development of the computer smart sensor, people recognize that the failure can be predicted before it happens or becomes significant. They developed predictive maintenance methodology. Later on, people tend to approach the machine and its problem like a health problem of a living organism. A machine can be sick and should be cured before its sickness becomes dangerous. We call this approach prescriptive maintenance. The main purpose in all these maintenance approaches to find a balance between two delicate situations in machine usage: minimize downtime and maximize lifetime of the machine. We want to use the machine as long as possible, but we don't want them to fail due to prolonged usage. We want to keep them healthy, but we need to run them to manufacture something. These two contradictory situations create stress on us. Machines can do different things, but whatever they are, whether they are laundry machines or sophisticated drilling machines, they nearly do the same thing and contain similar components. They consist of some rotation equipment, some other parts directing and manipulating these rotations. In modern machines, we call these parts motor, coupling, bearing, gearbox, shaft, and load. The purpose of the machine can be different. Maybe it can be a fan or pump or whatever. And these parts can fail and cause the entire system to shut down. The problem is, how can we understand if these parts are faulty or not? Can we learn if they have a problem as early as possible before the problem becomes very big and incurable? To understand if a human is healthy or sick, first we can ask them what kind of symptoms they have. Maybe they had a headache or fever. These can be the first symptoms that help us to understand what kind of ailment it could be. Humans talk. What about machines? Machines can also talk. Machines talk to us with the data they produce. When a machine starts operating, it generates some data because of the same universal forces. They create vibrations, sound, temperature, electromagnetic signals, and with the change in the fluid, they can tell us more about their health situation. If we are able to listen to this language and interpret their language, we can detect their health just like humans. We mentioned that the failure is inevitable. Machines start failing soon after installation. The life cycle of failure let us know how it happens and how a failure manifests from single fault to very sophisticated failure. The first system that we get from the machine is ultrasound data. Ultrasound is high-frequency sound beyond our ears' hearing capacity. Then vibration is a second vital symptom that allows us to understand if there is a problem. Vibration can even give us a hint about the future of the problem. But as in the graphic, we have to detect a problem in this blue area before it's too late. The blue area is where detecting the problem is very difficult, but solving it is very cheap. In the red area, we can detect a problem with even the naked eye, just by touching the machine and hearing the noise coming from it. But it's too late for many things. Any fault can cost just $10, and 1 hour of stopping can become a fatal damage, costing $1 million and causing a month of unplanned stoppage in the whole factory. Machines are an indispensable part of our civilization. Their health and performance directly impact our lives. we should keep them healthy, like trying to keep ourselves healthy. We should do our best to understand their language and let them talk to us.